Multiplying radicals is not as picky as adding and subtracting radicals when you need to have the exact same square root in order to add or subtract them. When you multiply radicals, as long as you're multiplying a square root with a square root, you're good to go. So this first example, we have 5 times the square root of 3, and it's being squared. So what does it actually mean to square something? That means you just take your 5 square root of 3 and you multiply it by itself. Alright, so now we've got all this multiplication to do. What you want to do is multiply the things together that go together. So what I mean by that is this 5 out front, because it's not a square root, you can't multiply it with a number that's underneath a square root. But this 5 can be multiplied with that 5 because they're both non-square root numbers. So that 5 times 5 is 25. And then we have the square root of 3 that we'll go ahead and multiply with the square root of 3. Now the square root of 3 times the square root of 3 is the square root of 9, and then the square root of 9 is just a 3. So it actually simplifies down to just 3. So we do 25 times 3 and we get 75 for that final answer. Anytime that you have a square root times itself, you will always get the value back that's underneath the radical. For example, I don't know, square root of 6 times the square root of 6 is the square root of 36. Well, you can take the square root of 36 and you get 6. So it's always that number underneath. So I can do this with bigger numbers that I may not know the square root of, like square root of 201 times the square root of 201 will just equal 201 without the square root. So you can shortcut through that. It's kind of a nice little trick to know about squaring square roots. Alright, next example, you've got the square root of 3 that's out in front of a set of parentheses. So that means we're going to take the square root of 3 and we're going to distribute it to both terms inside. When we multiply the square root of 3 times the 2 is not a square root, so I can't actually multiply those together and get 6. So I'm just going to leave the 2 out front and say 2 times the square root of 3. That's the best we can do to put those together. Now when I take the square root of 3 and multiply it by the square root of 15, because they both are square roots, those can go together. And then because that's a minus sign minus the square root of 15, it will still be negative. And 3 times 15 is 45. So when you multiply square roots together, you actually multiply the numbers together and they stay underneath the radical. So we have 2 times the square root of 3 minus the square root of 45. Our final answer should have all your square roots or your radicals reduced as far as you can go. That square root of 3 is good, but the square root of 45, we do have a perfect square number that fits into 45. 9 fits in 5 times. So we'll go ahead and take the square root of 9 and get 3. The square root of 5 stays the same. And then we'll bring down our 2 square root of 3 and the minus sign. Now to see, can we keep going? Are those like terms we can put together? Now that it's a subtraction problem, you have a square root of 3 and you have a square root of 5. Because those are not the same, we can't put them together, which means that will be our final answer right there. Alright, next example, we are multiplying 2 square roots together. The square root of 6x cubed times the square root of 8x. So what we'll do on that one is we'll just square root and we'll put them all together. 6x cubed times 8x. And then we'll go ahead and multiply. The 6 times the 8 gives us 48. X cubed times x is x to the 4th power. We'll add those exponents. So now when we take the square root of 48 x to the 4th, the square root of 48 doesn't have a square root, so we try to reduce it with perfect square numbers. If you think about your perfect squares, 4, 9, 16, 25, 36, which one fits into 48? 16 actually fits in 3 times. The square root of 16 is 4. The square root of 3 will stay the same. I put it off to the side a little bit, knowing that I still have to square root the x to the 4th. Alright, so now we'll take the square root of the x to the 4th. And when we do that, we ask ourselves how many x squares fit into x to the 4th. And because 2 of them fit in evenly, that's an x squared times an x squared. When we square root that, we do get x squared out front with no x's left over, which means that will be our final answer. Alright, last example, we have a binomial times a binomial, which means this is a foiling problem. Now, I do want to point out the difference between this example right here and this one up here that I rewrote because something was being squared. Do you see how this one has pluses and minuses separating two terms, making it a binomial? Those are the kind of problems that you'll FOIL. If it's just 5 times the square root of 3 and everything is multiplication, you're not FOILing all kinds of crazy things. You're just multiplying the things that go together. But this last example we will FOIL. So we're going to multiply our first terms. 4 times 3 gives us 12. Now we're going to multiply the outside terms. 4 times negative square root of 5. Because they both are not square roots, you can't actually multiply the 4 and the 5. So we'll just leave it as minus the square root of 4 times the square root of 5. And again, I did minus because you had a positive times a negative. Alright, now we're going to multiply our inside terms. Again, they're not both square roots, so you can't get 15 from that. It's going to be plus 3 times the square root of 5. And then you multiply your last terms. Square root of 5 times square root of 5 is the square root of 25, but we went through that at the beginning of the video. We can just shortcut and say we know that that will be a 5. Should it be a plus or minus 5? Because it's a positive times a negative, it will be minus 5. So for our final answer, if we have anything that we can combine, we'll want to go ahead and combine like terms. I do see a couple things you can do. Here's a square root of 5, and here's a square root of 5. So those will go together. And we also have the 12, which we can combine with this minus 5. So 12 minus 5 gives us 7. And then you have a negative 4 square root of 5 plus a 3 square root of 5. So we'll do negative 4 plus 3 and get a negative 1, and that square root of 5 stays the same. So that 1 is optional. You can leave it there, or if you don't like it, your answer can look like that as well. So again, in a problem like that with these plus or minuses, just FOIL like you guys are used to doing, combine like terms, and you're good.